Hello everybody, I hope I'm live right now, and let's simply get started from here on. So just a minute, let me make sure that everything's up and running. Just a minute. And this time we'll just simply get the things done so that we can just simply switch to the another thing as well. So let's simply, because we have to just simply go through it theoretically, because most of the code has already been written, so I have to just simply explain that. And this is how things are gonna be going on. So as for right now, we discussed about this thing, right, the last time. First of all, we were somewhere here, and first of all, we sort of got rid of this overall schema here. And if I can export it here, copy as png, can we copy it as png? Once it's copied, can we paste it over here? Let me see. Oh yeah, that's possible. That's good. So this is the overall schema of our project here. And apart from this particular thing, what we are gonna be having next here, that is having the overall thing. So in the API, we are getting sign up, login, creating the website, and checking the status of the website. So status check, we are getting all these things done. In the pusher, what we'll do, we'll just simply get the links and push them into the queue. So ultimately, QUEUE. Okay, so we are gonna be getting the links of the websites again from the database to get the links from DB and push them into the queue, because there can be many websites. Hence, that is why we are gonna be using Redis queue over here to just simply streamline the things for us. So that's the reason we are gonna be using pusher over here. And let's see, after that we are gonna be talking about the workers. Again, workers are gonna be just simply pulling them, and after the processing the things, and after that just simply acknowledging the process once that gets done. So that's what is gonna be happening inside worker here. So ultimately, if we just keep it simple, so we have a database, we have not even like that, we have a client here, okay. I'd better just make this diagram here itself, that would be better. So in this particular case, we have a client. So just a minute, just like this. So this is gonna be the client over here. How can I, okay, make it bigger, just like this. So this is the client. That client just simply saved its info in the database. So that's gonna be a database for the client info as well as for the website info and all. So ultimately, that's gonna be DB, right? So this is the DB that we have, for example, and this DB will just simply contain the information. Ultimately, when it comes to the database, so it may have a few things. So in the database, there can be user info, there can be web site info, and apart from that particular thing, there can be website tick info, and there can be region info. So these types of infos we are going to be having inside the database. So this is what we are going to be having inside database, and the client actually saves all this information in the database. So this is how it just simply goes on, and all these things happen in the API section. So whatever is being done here, that is being done on the API section. So on the API section, we are just simply getting this particular thing done. And now the next thing is that of course there's gonna be server as well. So ultimately, somewhere in the middle, there's gonna be server, or I can say API server. So I will have an API server somewhere in the middle. So that's gonna be the API server. The request will go from the client to the API server. API server will be just simply storing all this information to the database. So this is how the request is actually gonna be stored in the database. Apart from this particular thing, I'm actually gonna be having a I'm gonna have a pusher here. So pusher server, that is mainly responsible for pushing the events and all. So I will have this pusher server over here. And once I have this particular pusher server, so what this pusher server do, that it will get the data from the database. So this is how it's first of all gonna be getting the data. So first of all, it will get the data from the database. Ultimately, it will be getting the website info over here. So web site info over here. So it can just simply get the website info from the database. Once it gets the website info from the database, and that too in fixed intervals, suppose in 3 minutes or something, because if we get it in every second, that's gonna be crazy. So suppose in every 3 minutes or 3 seconds, it depends on us exactly what should be the interval. It should be 3 seconds actually. Like what is the inverter that we used here? In our case, 3 multiplied by 60 multiplied by 1000, that is actually equivalent to 3 minutes. So okay, in every 3 minutes we are checking whether the website is up or not. That is fine as well. So the interval can actually be anything. So we will have some fixed interval over here in fixed interval. So that's gonna be a fixed interval. So in fixed interval we are gonna be getting the list of all the websites from the database, and suppose in 3 minutes or something, or the previous one is fine, in fixed interval. So ultimately we are going to be getting the website in fixed interval, and once we got the website info, so this pusher ultimately, this will have the website info, and once it has the website info, it is just simply going to be pushing it in the queue. So there's going to be a queue we'll have here. Suppose this is the queue that we have. So this is nothing but a queue. So inside this particular queue, this pusher will be just simply pushing the requests. What kind of request? It will just simply it will be pushing the request with the information of the website that it gets, and now worker has to just simply get the request from the queue and just simply process that. Okay, so this is how the overall things are gonna be going on. So this much we've done. So ultimately this is the client send the request, we'll be getting this is the first part, and if I can change the color, and this is actually the second part over here. So this has been the first part going from here till here, then this is the second part, and let's continue move to the third one. So this is how we are going to be going ahead. As for this queue, let me cut it and let me paste it here. So this should be fine. Okay, apart from this particular thing, what else do we need to do? So we have gone through this pusher section, and if I actually show you that, so over here in every, like first of all we are running this main function, and this is nothing but the pusher server here. So this is what we are doing inside the pusher server, and we are just simply pushing running this particular main function in every 3 minutes. So 1000 milliseconds multiplied by 60, that simply means 1 minute. So 1 second multiplied by 60, 1 minute multiplied by 3 minutes. So 3 minutes are here. So in every 3 minutes it's gonna be running, because we are using set interval over here. And here, first of all, we are making a request to the database. So Prism website find many, we are just simply gonna be getting the URL and the ID over here. So in the website info that we are getting, we just need to get two things. We need to get URL and the ID of the website. So we have the URL and ID of the website. With the URL, with the help of the URL, we'll be hitting that, and with the help of the ID, we'll find it and update the info. So this is how we are gonna be getting the things done. And websites, that's fine. And after that we are just simply adding it. X add bulk, this is nothing but a function that I have created over here. So what it does, that it is just simply used for adding the website info in the queue. So if I actually show you that here, so we have X add bulk, there can be many websites, that is why we are just simply running a loop over here. And then await X add, this is again one of the methods over here. So if I just simply functions actually, so over here await client X add stream, and this star, I'm simply providing the stream name over here. The stream name is better uptime website, that's the name over here. That name can actually be anything, but make sure that the same name you are using. This star ultimately wildcard is actually being used for assigning the ID to it automatically. We'll be just simply going through that, and then as a payload we are just simply passing URL and ID. So this is how we are just simply going through the things. This is how the things are actually gonna be added. Just a minute, give me a moment, I'll be right back. Alright everybody, it's time to just simply continue with that. So ultimately, how do I know this is the last function, and this is the last method that we have to call, and we have to have a client object over here. How do we get the client object? We get the client object like this. So client create client, so we are creating the client. This create client automatically gets the URL. So I think we don't even need to mention the URL over here. If you have Redis running on your computer, it automatically gets the URL. And if there are any errors, it's gonna be throwing the error, otherwise it's gonna be connected, hence you are gonna be getting the client. Once you have the client, you need to have the stream name, and this stream name is gonna be used every time, whether we are just simply adding it, whether you are just simply getting the list of all the push the request, or you are, so ultimately what you are doing, you are just simply pushing this particular request. What is this request? This request contains the URL and the ID, and that is it. You are providing the stream name where it needs to be pushed, and that is it. Okay, so this is how the overall things done. Then you can first of all push it. Then the second thing is that you can read as well. So there are many things, but whenever you are doing these operations, so one of the most important thing is the stream name that you have to have over here. Again, if you actually go through the documentation, you will know about everything. So let's simply go through the documentation. If possible, I'm gonna be turning it on so that I have the dark mode here. Well, dark mode is not really possible to get here if I'm not wrong. Yeah, so let's forget about that. Let's simply start going through it from the beginning. Alrighty, so we are mainly gonna be using Redis stream over here, and the first thing comes, that is if I search Redis over here online, Redis npm. So Redis npm, this is the thing, and wait for a while. Verify you are a human being. Alrighty, so this is the Redis package. How many times it's gonna be verifying? Okay, so node Redis, this is the one. First of all, you need to install Redis, and the second thing is that you need to run Redis on your local. If you are using Docker, so Docker run, and you have to run Redis on this particular port number. You are gonna be running it in the detached mode. Then you install the Redis. Once the Redis is installed, and then const client await create a client on either this, and if there's no error, then just simply connect to this. So this is what we've been doing, right? And that is it. Once you've done this, you got a client. Once you got a client, then remaining things you have to handle. So what is the next thing? The next thing is that again, these are the setting. You can actually set the some values in the Redis, or you can just simply get the values in the Redis, and you can do it both the ways. Both the ways in the sense, you can do it like this using the CLI. So like I'm just simply setting the name, I'm setting the password over here in the Redis, and then I'm just simply getting them as well. So you can get the values in the Redis. And the second thing is that you can actually push the the requests in the database with the payload. So that's what we are discussing over here. Again, you can do this thing using the command line commands, and again, you can get all these commands in the documentation itself. So that's what we are gonna be going through right now. So there's a lot. This is all about just simply using Redis to just simply save some of the values. Coming back to this one, we know how to get the client. Now let's talk about this particular stuff. So a Redis stream is a data structure that acts like an append only log. So we can just simply append the things over there, but also implement several operations to overcome some of the limits of typical append only log. These includes random access of one time and complex consumption strategies such as consumer groups. So it also supports consumer groups over here. You can use streams to record and excuse me. You can use streams to record and simultaneously syndicate events in real time. Examples of Redis stream use cases include event sourcing, tracking user actions, clicks, etc. Sensor monitoring readings from devices in the field, and then notifications is storing a record of each user's notification in separate streams. Okay, Redis generates a unique ID for each stream entry. So the star that I was talking about, this particular thing in the request as well. So if I click on JavaScript node Redis, so you will be getting the the code that was used in my pusher. I think that's the pusher, or that's the pusher actually. So in the pusher, whatever code I've written, I just simply got the reference from here only. But I think it's gonna take some time. Wait for a while. Okay, so this is it. It is just simply saying that you need to have the stream name over here. You need this star that I was just simply talking about. So you can go with anything. You can go with the Redis CLI command, or you can just simply go with the JavaScript. and then you have to just simply give it the payload, whatever data you want to store, and this star is make sure that you are gonna be getting the unique IDs. So this particular thing here, Redis generates unique ID for each stream entry. So this is automatically gonna be generated. You can use these IDs to retrieve their associated entries later, or to read and process all subsequent entries in the stream. So ultimately you can just simply get the entries, you can just simply read them as well. Note that because these IDs are related to time, the ones shown here may vary and will be different from the IDs in your on Redis instance. So ultimately what happens when the ID is actually generated, the example must be given here. So this kind of ID is generated. The first one is the current timestamp, and then you get the 0. So 0 following the current timestamp. So this way the current timestamp keeps changing. So the IDs keep changing as well. So this is how it is simply done. What is this download markup? I'll just simply go through it. By the way, let's continue. Redis streams support several timing strategies to prevent streams from growing unbounded and more than one consumption strategy. See xread, xread group, xread. So xread is mainly used for reading the request that's been pushed. Xread group, you can read the request of all of a group. Xrange is gonna be used for reading the request in a particular range, starting with Redis 8.2, ag delete, ag x, ag del, x del x, and x add, and commands provide fine grained control. So ultimately x ag del just simply deletes the acknowledge if I'm not wrong. X delete x add. I know about x add over here, that is nothing else. We will have to just simply go through it. Commands provide fine-grained control over how stream operations interact with multiple consumer groups, simplifying the coordination of messages processing across different applications. Okay, that is fine. Okay, theory part. Beginning with Redis 8.6, Redis system support idempotent. What is idempotent message? Processing. That the message idempotent means something that doesn't change even if you have made many requests. So beginning with the Redis 8.6, Redis stream support idempotent message processing at most once production to prevent duplicate entries when using at least one delivery patterns. This feature enable reliable message submission with automatic duplication. So ultimately this is how it's going to be going on. The important thing is here that first of all, what we have to do, we have a queue, we have to push the things in the queue. So we have to just simply add the request in the queue. So when our racers pass a checkpoint, we add a stream entry for each racer that includes the racer's name, speed, position, and location ID. So ultimately they have their own example. So what we have to do, we have to add to the client, and ultimately the stream name should be here. This star is just for the ID, and whatever information we want to save with that particular request, we have to just simply do that, and that is it. So this is what we have to do, and that's what we are doing over here. Coming back to this, so first of all, what we have to do, we have to make a request to the database. That's something we are already doing. So we are already once the client, the user actually saved everything, then we are gonna be, in a fixed interval, we are gonna be getting the website info from the DB, and we are gonna be pushing the URL and ID in the queue. So this pushing thing is something that we are discussing over here, that how we actually push. So when it comes to pushing, so first of all, you need to have the client, that is for sure. Again, you need to have the stream name, this particular part here, and at the end of the day, this is the this is what is used. So await client x add, you need to have the stream name, and this is the payload that we are going to be passing. This is for the ID, so that it gets automatically generated. So this is how it's going to be going on, and this is exactly similar to this. So if we actually have a look over here, Redis streams, coming back to this particular point over here, so x await x client add, name, star, and the payload. That's what I'm doing there, right? So we are just simply pushing it using this, and because we are gonna be getting many websites from the database. So ultimately, whenever we are making a request, so in every 3 seconds, this particular function is gonna be running, and at that time we are making a request in the database, and from the database we are actually gonna be getting the list of all the websites. Hence those websites can be many, and because of that thing, we are using streams over here. The main region of using streams, because we are gonna be getting many websites. Okay, and that's again gonna be in the form of an array. As we are getting many websites over here, it's gonna be hard for Redis, or it's gonna be hard for any server, because at the end of the day, what we have to do, once we got the websites, we have to make a request to the uh, using the URL. Ultimately this is how it's gonna be going on. Once we got the websites, we are gonna be getting the URL of that particular website. Once we got the URL, we have to make a request. And if there are many websites, suppose websites in lakhs or something, probably in crores or as well, I mean that can also be one of the cases. So if the websites are in lakhs, alright, so ultimately websites are gonna be in lakhs, suppose ultimately lakhs, come on, I should be able to write. So if the websites are in lakhs, and making 1 lakh request at the same time is gonna be troublesome. Ultimately server may not be able to handle that, and because of that thing we are gonna be using streams over here. So ultimately Redis streams are gonna be used over here. So as Redis streams are being used over here, so what we are doing, once we got all the website lists, so web site lists, once we got that, we are gonna be pushing, or we are gonna be just simply adding them to the queues. So I'm gonna be just simply adding them to the queue because the throughput of the queue is far higher than the throughput of a server. Hence adding is gonna be possible. Once I've added them, then I will have my workers. They are gonna be just simply pulling them or getting them one by one, and just simply they'll process whatever processes needs to be processed. So they'll do whatever needs to be done, and after that they'll acknowledge in the sense they'll say, okay, we've done this thing. So they'll acknowledge the request, that okay, the request whatever we have to do, this has been done, this has succeeded, or this has failed, whatever. So this is how the overall flow is gonna be looking like, and that is why we are using streams over here. Pretty simple. X add bulk, that's pretty simple, right? So X add bulk, here we have many websites. As we have many websites, we'll have to loop through them. And if I'm not wrong, what we are doing over here, that we are hitting our database again, not hitting our database actually. We are actually getting all the websites from our database in every 3 intervals, and then we are saving it in the Redis stream, ultimately Redis queue, one by one. So we are just simply looping through them, and then we are just simply adding them. As for this adding them one by one, hopefully Redis provides some kind of method that actually adds the array directly in a queue. So we will we still have to figure it out, or let's take this thing out directly. So just a minute. If we want to add something to the Redis stream queue, so the first way is that using client.xadd method, right? Is there any another way, so that if I have array of many requests to just simply add, we can directly add the array in the queue, or we'll have to just simply loop through the array and add the requests one by one. So let me see what it says regarding this particular thing. You are thinking in the right direction, but here's the clear reality. In Redis streams, the primary way to add data is indeed await client xadd stream name. So ultimately my stream, this important point, no shortcut for arrays. Redis does not support adding multiple stream entries in single add call. So even if we have an array, you cannot do something like this. Okay, so what do you actually do here? You just option one, loop the basic way, pipeline, better and efficient. Instead of sending requests one by one over the network, you batch them. Batching them in the sense, we create client.multi. So this client.multi means this is for multiple documents. So for const items of data, so we are just simply gonna be looping pipe.xadd, and we are gonna be adding it in the pipeline. So instead of and then await pipeline execute, this is still multiple xadd commands, but sent together much faster and reduces the overhead. So ultimately, instead of using client.xadd, we are actually gonna be creating a pipeline. In the pipeline, we are gonna be adding them, and then we are gonna be executing the pipeline. Hence, it's gonna be sort of, I mean, all the requests are gonna be sent together, reduces the network overhead. So that makes sense as well. As for this particular thing, we can. This is the second way, so I'm gonna be just simply having this example here as well. So this is one of the second ways. Let me cut it from here. we'd better use it in here. So whenever I'm just simply adding it bulk, so in this particular case, so client pipeline is here, and the data is nothing but website. So websites, again from here I'm gonna be getting the website, and this website contains what I'm gonna be using website over here. That website for sure contains two things, the URL and all. Okay, so this is how we can just simply get it done. So this is just one of the another ways, to get the same thing done. So ultimately what we will have to do here, we will not have to call this particular function here, rather we will not be even using client. Using client, we created a pipeline, and then we are executing the pipeline at the end of the day. So this way it have been done as well. So this is the another way, and this is how I just keep learning. Okay, pretty simple. Coming back to this one, so we've got the X add section done. We even have X read. This is something interesting. X read is gonna be coming when we actually have to get the information or something. Let's see when we are using this X read thing here. So it turns out I'm actually inside Redis function. That's interesting. So X read is gonna be happening in the group. So ultimately what we are doing that first of all, we have the pusher. In the pusher, what we are doing, we are using X add bulk. We are just simply passing the websites over here, and as we are passing the websites over here, the request actually goes to this Redis over here. This is the another server that we have that is actually running here, that handles everything related to Redis. Over here we have the client, we have or some functions that are actually being exported from here, and similarly we have X-read group. This is actually X-read group, X-act. These are the things that are used in the worker. The top level things are used inside the pusher. So they are gonna be for pusher. I mean, it's quite understandable, right? But still it's good to just simply for workers mention it here. So this is how it's gonna be going on. Alrighty, we have gone through this pusher section. Ultimately this is the job of the pusher, that it's gonna be just simply getting the info of the website in fixed intervals. We'll be pushing the request in the queue. The job is done. Let's go ahead, and this time workers are gonna come in the picture. So this pusher server is done, API server is done. Let's talk about workers right now. So workers server, this is how we are gonna be having it. As for the color of this, I'm gonna be changing it to the green. That would be better. So this is the worker server this time. Okay, so we have gone through pusher. Let's talk about the workers over here, and this is actually gonna be the last section over here. But before that, it's good to just simply read through it. So first of all, this is how we can just simply add the stuff. Apart from this particular thing, we even have Redis CLI way here. Again, it just takes some time to reload the stuff for some reason. Let's see. Let's wait. What else? It does take some time. I mean, it maybe has a lot of things. So ultimately we can do the same thing. We can add it using the the server, the normal commands, the way I written the command. We can just simply make a request. We can even use Redis CLI over here. So we have to add, this is the name of the stream that we have, star we are gonna be using, and this is the data that I want to save. So the idea is that this speed was this, position was this, location was this. So using this, you can just simply save the information as well. Similarly, I have these things mentioned in my notes as well. Like there are two ways. X add better uptime. So this is the website name, stream name. Star is here, ID 1 and URL google.com. These are the two things that we actually want to save. So this way we can just simply add the things in the queue ultimately, and there can be multiple consumers. So ultimately many consumer groups we can create. So this is that's the same thing we are going to be discussing right now. And then we have X range. Using X range, we can just simply get the range. So we have to just simply specify a timestamp, ultimately the ID of the request, and then we can mention the count, exactly how many requests we want to check from the queue, and we can just simply check them. Apart from this particular thing, we can even read them. Once read, they are not gonna be there anymore. So you just simply get the chance for reading only once, because as you read them, they just simply gets removed from the from the queue. And X group create, we can even create a group. There can be this is X group means consumer groups we are gonna be creating over here. Why they are needed? There should be different consumer groups. They will have their own consumers, and this is gonna be important. because if I'm not wrong, just a minute, when it comes to sending the request, right, to a particular server, so if there is a website link that I have got in the queue, now I have to make a request to different origins, different regions. So there can be India region, there can be USA region, then can be Africa region. Hence we need to create multiple groups, and those groups are gonna be getting the reading the queues from the reading the request from the queues, and will be just simply getting it implemented. So this is how it's gonna be going on, and we'll tackle it. Excuse me, just suffering from sneeze a bit. Okay, so this particular thing is done, and if I just simply go to this particular section, so this is how we just simply read two stems integer from add this. So x range, using the range we are just simply adding it. All the commands are here directly. You can read it using the JavaScript as well, but the only thing is that it takes some time. So I'd better just simply duplicate it right now. Oh, that doesn't look good at all. So let me do one thing. Let it be here. And JavaScript. Okay, just suffering a bit. Common thing. Okay, so this is actually being loaded here. So once it is loaded, again this is a CLI command, xrange, the name of the stream, and also this is how you can just simply read it. Xread count 100 block. Again we can do it practically as well. Doing it practically in the sense, just a minute, wait it. So let me do one thing. Am I running the things here? These things can be done practically as well, hence I'm gonna be doing them practically too, so that it's we have a better idea of the things, how they are just simply working here and all. So exit, clear the things here, and docker desktop start the docker first of all. So they are gonna be started, and the docker process status, of course none of them are running. PSA docker two Redis ones were running earlier. Let me remove both of them. So docker remove this one and this one. Ultimately both of them are gonna be removed. Docker PSA. So this thing is done. Second thing is that Postgres SQL is being used over here, so of course sooner or later I'll have to run it. So docker start and Postgres DB here. So this is started. Docker process status, we have this running, and now we have to run what? Docker run. The port mapping is gonna be 6739. Let me see. In here, so that is 6379 actually. So 6379 column 6379. So this is the port number, and we have to write in the detached mode, and we have to run Redis here, right? So hopefully the commands that I've written, they are the right ones. So docker run port number in the detached mode and Redis CLI. Okay, so I'm just simply gonna be running it here. So Redis is running, docker process status. So ultimately we have Redis running here right now. Once the Redis is running, then we can just simply get some of the things done. The way we write these things, ultimately you have two options over here. I can have them side by side, that would be better actually, instead of having them in separate windows. Not even windows, actually browsers. To be precise, they are tabs actually. Okay, coming back to this particular thing. So we have this stuff here. It hasn't really changed, right? So I wanted to make it a JavaScript node, or probably it changes in both at the same time. Let me see if it actually changes or not. And if it actually behaves like that, in that particular case I will one Redis stream here, and we'll just simply get the job done here as well. So Redis streams, this is the documentation, and here I'm gonna be switching to JavaScript, so that should be fine. So instead of having the same, okay, here even it does the job here as well, so we don't really need to worry about it. The third one, so let's close this. Okay, coming back to this thing over here. So first of all, we just simply added it, and for adding it, this is the normal command, and that's what we are going to be implementing it here. And apart from this particular thing, if we want to add using Node.js, ultimately JavaScript, so we will have to use this particular client over here. We'll have to call xAdd function method over there, and then we have to just simply provide whatever we want to add here, right? So let's simply go with this client command line right now, and let's simply clear everything. Docker process status, Redis is running, so Docker execute interactive mode. This is the Redis that is running right now. So copy paste sh, I'm gonna be SSing, and once I'm inside that, ls, we actually don't have anything. Redis CLI, I think this is the command to just simply enter that. Again, that should be mentioned somewhere, that isn't really mentioned here, but I have saved in my notes. And has that been mentioned here? Okay, not really. You are just simply getting the methods, so how you can use them using JavaScript and all. So you are getting those features here, and that is right. So ultimately, if you want to enter the Redis CLI, so you have Redis -CLI command. Now you are inside the Redis CLI, and once you are inside the Redis CLI, so you can just simply get to know about anything. So first of all, what is the thing? First of all, we had to just simply add the request. So this is the way to just simply add it. Okay, I need to copy and paste, of course. It's gonna be time taking. Let me copy it directly from here. So this is the one that I have. So I'm gonna be saving these things here. So ultimately that is nothing but xAdd. We have to add, and then I'm already getting the suggestions. Key. What is the stream key here? So that's gonna be better uptime colon website. Suppose this is the one. Okay, apart from this particular thing, we are gonna be using star over here, so that star is mainly used for generating the keys directly. The key is actually gonna be generated, so you will get the idea. And then the field value. So suppose ID is gonna be 1, and URL is gonna be www.google.com. So these are the things that I'm actually saving inside the queue. You can just simply keep going on like this. But if I just simply add this, so this is the ID that got generated. So this is the timestamp, current timestamp, and the 0. So this is the first one. Similarly, I can add one more. So can make the ID 2. ID can be anything, actually depends on exactly what kind of ID you wanna keep here. And facebook.com, www.facebook.com. This is how you can just simply keep adding the values. So ultimately, this is these timestamps are gonna be different. This is the different timestamp compared to this one. So this way you will just simply keep getting the values and all, and this way it doesn't really matter. You can just simply store as many values as you want. So this way I have stored many values. Ultimately 1, 2, 3, 4, 5, 2, 4, 6. So ultimately 6 times I just simply pushed them in the queue. So ultimately what I've done using the command line in the queue, I have pushed the 6 payloads, 6 requests. Now I have to read them. So when it comes to reading them, so if I actually go here, so first of all, you can even push using the command node, and the second thing is that use reading them. So when it comes to reading them, so you can read them using the command line. So over here for reading them, you can use xrange race France, and this is the name. This is the starting ID, exactly at which ID you want to start, plus how many counts you want to read. So let's simply go with this. We are gonna be reading it xrange, RANGE. And what is the key? Key is nothing but better uptime and website. Again, what is the starting point? The starting point is gonna be this. For example, this is what we are gonna be taking as the starting point here. So paste it here. And what is gonna be the end point? You can even mention the end point. So you can just simply have this particular value here, and that is it. And if we just simply enter it, so we are gonna be getting all the 6 results. So this is the first request. It had the ID 1, URL this. Similarly, the second one, third one, fourth one. So ultimately 6 of them we are getting here directly. If I run it again, we will get it again. It's pretty simple. We'll keep getting it, and we can even specify the count over here. So count is gonna be, suppose I want to get only 2. Starting should be this, ending should be this. So within this range, I'm gonna be getting 2 of them. So if I just simply run this, I'm just simply getting 2 of them, because we have 6 at the end of the day. So we can just even get the 5 We can even get 10 of them, but we do not have 10 values inside the queue, hence we will not get, we will only get 6 of them here. So this is how we are actually gonna be going on. So this is the one of the first things here. You can even read them, and the only thing is that when you are getting through in some range, so you are just simply knowing about them. Read up to 100 new streams intage, so let's simply read to that. Read to stream intage starting at this particular index. We've gone through this anyway, and once read in range, read up to 100 new streams intage starting at the end of the stream. Just a minute, give me a second, I'll be back. Alright everybody, let's continue. So what I was just simply saying that you could have read them in some range, and you could have read directly as well. So read up to 100 new streams integers starting at the end of the stream. So it will be, if you are using dollar, this dollar simply says that it will be starting at the end, and block for 300 milliseconds if no integer are being written. Pretty simple, it's gonna be blocking. So ultimately uh, what should actually happen over here, that this dollar represents the last one, and as you get the streams, you are just simply gonna be reading them, and if there are none of them, so you are gonna be blocking it for 300 milliseconds. After that you are gonna be dropping it. So simple. If there are streams, you are gonna be reading them. So from the current timestamp, if there are streams, keep reading them, and if there are not, none of them, block it for 300 milliseconds, and after that again, that is it, the job is done. So this is one of the ways. So if we try to read that, so x read, and we have to specify the count exactly what should be the value. So suppose we want to count 2, we have 6 requests in here, we just want to count 2. As for the milliseconds, we can block it, but we are not gonna be blocking it because we will not read from the current one. And streams, the key, what is the key over here? The key is, in our case, that is better uptime website, and that is it. And the last thing that we have to have here, so count is done, block is done, streams is done. Dollar, if I use this dollar over here, this simply means it is gonna be starting from the current timestamp. We can even mention a timestamp that we have to start from here or something. Suppose I have to start from the first one, so I can just simply mention this timestamp over here, or we can mention 0. So 0 means it will be reading from the beginning. So let me see, ultimately in my notes we have few options over here. We have 0, that is starting from the beginning. We have dollar, that is merely from now, and we have a timestamp that will be starting from that particular timestamp. So it's pretty simple. Let's simply click this, and it will be just simply reading 2 from the beginning. So it has already read 2. I will run the same command again, it has read the remaining 2. I will run the same command again, it has read the remaining 2. So ultimately we had 6 values, I read it 3 times. That simply means 6 requests, they've been read. Now if I run it again, I'll keep getting it anyway. I think I need to acknowledge this. Okay, let's keep it simple. As for reading, you can just simply keep reading them, that doesn't really matter. But as soon as you acknowledge them, they just simply get removed from the queues, if I'm not wrong. So count 10, not the range actually. Six, let me have 6 over here, and let me see. So we are getting all the 6 ones, and if I read it from some timestamp, suppose I want to read it from this timestamp over here. So let me add this timestamp too, and now I'm getting only 2 of them. I read from this timestamp, so of course this wasn't added, and the remaining 2 ones, or 2 of them, they just simply got added, and we'll just simply keep getting the result as the contain 2 requests here. Pretty simple. We've gone through this particular thing, and all these things we like all the commands I've written here, and then we can even generate the we can generate the groups, and using the groups you can just simply read them. So this is also one of the ways. The question is, why do we need to generate the groups? Ultimately consumer groups, because we have to monitor many countries, and we are going to be making the request to them, so that is why. Okay, and apart from this particular thing, let me go through the code right now. Over here we've gone through this first of all, and ultimately we done adding, and now we have to move to what? We have to move to the next section, that is the workers. So we've gone through this particular section right now. Let's start going through the worker section. So in the worker section, what am I doing here? Okay, in the worker section we have again a main function, we have a fetch website, and many more things. Ultimately there is this main function that gets called once. Okay, and as that gets called once, so worker starts running, and worker will keep running again and again. So that just needs to be called once, and that will just simply keep running. That simply means as soon as something got pushed in the queue, so over here this is the queue, this pusher will be responsible for pushing something in the queue. As soon as something gets pushed in the queue, worker will just simply pull it, or worker is gonna be getting it from the queue and will process it. If there are there could be possibility that the pusher has quite good throughput, hence it will be able to get many requests at the same time, and it will be able to push them in the queue. But worker servers, they are not that much capable, hence they are gonna be getting they are gonna be processing the request at their own pace. So that could also be one of the things. Okay, by the way, let's continue. So we have worker servers, they are just simply gonna be getting them, and once they just simply get, they'll just simply process it. So ultimately they're simply gonna be processing whatever the process is required, so they'll just simply get this particular thing done. Once that is actually processed, that simply means after that they'll just simply acknowledge. So first of all, when it comes to reading them, because we are reading them in a group. Why do we need to read them in a group? Mainly because we want to create many groups. We want to have the region ID, we want to have the worker ID. Having the worker ID is not really a problem, we will be providing that. And the worker ID, what do we have in the environment variable? This is the worker ID. Again, we have to create a group. So whenever we create a group, suppose this is first group, this is second group, ultimately this is the queue that we have, right? This is the queue, and there's gonna be what? There's gonna be pusher server. Okay, so pusher server is gonna be just simply pushing the request in the queue. So this is the first thing. Over here on the other side, I have worker servers. So ultimately I have workers. Okay, and it's not like there's gonna be only worker, rather there can be many. So ultimately many consumers, we mainly call them consumers. There can be many consumers here. So there can be consumer number 1, there can be consumer number 2, there can be consumer number 3. So this way there can be many consumers here, and as there are many consumers, so these consumers can, again, if I actually talk about the overall structure, how it looks like. So in the queue there are topics actually. So these ultimately there are many topics. So these are nothing but topics here, so I can just simply name the thing here topic. This is the overall structure of a queue. So there are topics. This can be topic number 0, and this is the topic number 0. This can be topic number 1. So this way we have many topics here, and those topics, they have the partitions here. So this is the partition number 1, and this partition is called the queue ultimately. So this is the partition number 2, and this way it just simply keeps going on and on. And similarly this one will have the same thing. And whenever the pusher server is just simply pushing, it will give the topic name, it will give the partition name, and on the basis of that thing, the request is gonna be pushed in one of the partitions over here. Again, these partitions further, they can have offsets over here. So there can be multiple offsets just like this. And similarly we will have many consumers. They are gonna be just simply connected to these they are gonna be connected to these partitions over here. So it is gonna be just like this. Okay, so there can be many of the consumers, they may be connected to many topics here, many partitions of different topics here. So this is how it's gonna be going on. So ultimately what happens here that one partition, suppose this is the partition that I have over here. So okay, this is okay, that's fine. So ultimately what you have to keep in mind over here, that one partition can get one consumer or partition, I'm getting confused here. I'm getting confused, just a minute, let me just revise one more thing here directly. Okay, Notion, I just covered the HLD section and now here I am getting confused, not this one, yeah. So where did I cover this particular thing, PubSub model messaging queue, right? So this is where it was covered. That's crazy, but okay, let's go through that. I'm just getting confused about one thing. So here we are. So this was right, okay, fine. So we had a consumer group over here, there were many consumers, and one consumer could connect it to many partitions. Yeah, that's this is how it simply goes on. So let me close this, let me be back to this particular one here. So the thing is that there were these many consumers and they were just simply getting connected, and what I meant here that one consumer may be connected to many. So suppose this is the consumer, so this may be connected to many partitions over here. Okay, so this could this is also possible that one consumer can be connected to many partitions, but one partition cannot connect to many consumers. So if you think that ultimately we have these two consumers over here, right? So if I want to make it like this, that okay, I have this consumer, so if I want to make it like this, it will work, that this particular consumer is connected to this partition as well as this partition. But if I want to make it like this, that this partition has this consumer as well as this consumer too, this is not possible. So that is where it gets problematic, that the two consumers from the same group cannot be connected to the same partition. And because of this particular thing, we created something called consumer group. So to resolve this problem, what we did, to resolve this problem, we created consumer groups. So this is the consumer group 1, this is gonna be the consumer group 2. They will have their own they'll have their own consumer. So consumer 1, just like this, and similarly there can be multiple consumers. So this is the consumer 1 here, this is consumer 1 here, similarly they'll have consumer 2 here. So the benefit of creating group, that's what I'm going to be discussing over here. So this thing is going to be consumer 2 here. Now what is the benefit? This is the consumer group 1, again 2 of course. So this is the consumer group 2, and similarly we have consumer group 1 over here, just like this. So what is the benefit of creating this? Now we have two consumer groups, they have of course multiple consumers under them. So what will happen, this particular consumer can connect to this particular partition over here, that is fine. Again, this one cannot connect to the same, because of course two consumers from the same consumer group cannot connect to the same partition, so it can definitely connect to the another one. The benefit is that we can connect the consumer from the second consumer group to that. So ultimately what is happening here, that one partition cannot connect to the two consumers from the same group, but one partition can connect to two consumer groups from different consumer groups. So what is the benefit of using this? The benefit is pretty simple. We know about PubSub model, that publisher and subscriber model. We want many consumers to be listening getting the request from a partition, hence we can get it here as well as here. So ultimately there can be multiple consumers connected to the same partition, getting the same requests from the partition. So this is how it's just simply gonna be going ahead. I hope it does make sense. Ultimately, forget about this exactly what is the real implementation of it. This is sort of the interview question as well, that two consumers from the same group, of course they cannot connect to the partition, same partition, but two consumers from the different groups, two separate consumer groups, they can just simply connect to that. So this is how the overall things they just simply go on here. Just a sec, let me delete this, it's quite big one, so let me keep it here. So this is the overall architecture that looks like. Never mind, let's continue with this thing. So ultimately worker servers will have a lot of consumers the way we have here. So for that thing we will have to create consumer groups, and hence we are going to be creating consumer groups right now. So when it comes to creating the consumer groups, so coming back to this one, if I go to the worker section here, workers index.ts over here, so we have two things. We have the region ID, exactly which is the region that is being used, and which is the worker, what is the ID of the worker. So ultimately when it comes to these workers, so first of all we are going to be creating the group in the sense that is sort of a region, right? So the consumer, we are going to be we are naming it one here. The consumer group can also be named as one or anything, or even India. So this is the ID is this is the region ID or the consumer group ID. Suppose this is for India, so we can create a consumer group for India, another one can actually be for America or something. So this way we can just simply keep going on, and they will have their own workers in the sense consumers they will have. So this can actually be for USA or something. Okay, so this way we can have multiple consumers, they will have many workers in them. Right now we have 2 workers here, and here I am doing the same thing. We are getting the region ID. This is nothing, this is not the region, this is the region ID of what? This is the region ID of the consumer group that we have created. So if I show you the environment variable over here, this is the ID that we have. Hopefully, no, this is the main region ID. Just a sec. How do I know this is the main region ID? Because this is the ID of the database, Postgres database. Hopefully this is how it just simply goes. And we have the worker ID over here. So how they are just simply getting together? Let me see. So we have xread group. It just simply takes 2 things. Xread group takes the worker ID and takes the region ID. Okay, worker ID and region ID. This region ID section. Okay, got it. Ultimately what I did, the region ID that I actually have over here. Okay, the same region ID is specified. I mean, this is the ID of the what? This is the ID of my region first of all, and the same ID is the ID of the group that I created. So I created consumer group here, right? So consumer group I created, I assigned the same ID to the consumer group, and because of that thing, the region has the same ID, the consumer group has the same ID. The benefit of using this is that the consumer group has the same ID, the region has the same ID. So using the same ID, I'm gonna be able to find the right region, and I'm gonna be able to find the right consumer group, and they are connected to each other. Hence that's good stuff here. Okay, the ID can actually be anything. The ID could have been one here as well. It's completely up to you. And as for this worker ID, it can be anything. If you name it 1, the worker ID is gonna be 1. If you name it 2, the worker ID is gonna be 2. So ultimately, if you have only 1 worker, so that's gonna be assigned one ID. If you have 2, so you have to assign the IDs over there as well. Okay, so this is how this simply goes on. And coming back to the worker thing, so we just need to have the region ID. We need to have the worker ID. Good that you are already gonna be getting the region ID. How? Because over here at the top you already have the region, and in the region you have the region ID. Okay, so you will be getting that. That's gonna be pretty much simple. And as for the worker ID, the worker ID can actually be anything. It can even be ABCD, whatever ID you assign. So the new worker will be getting that particular ID here. So no need to worry about that. Then we are just simply running a while loop over here. Once running the while loop, we are checking whether they exist or not. And just a sec, yeah. So after that, we are just simply reading it from the group. So we are giving it the region ID, we are giving it the worker ID. Worker ID makes sense that okay, worker can be anything, so the ID can be anything. This region ID, we are actually able to use the region ID over here because my group X read group, right? So we are just simply reading the group. So reading the group has the same ID as the region ID. Because of that thing, we are gonna be able to read that. If I talk about this particular thing in Redis streams here, so we've gone through these many things. Performance, stream basics. Okay, so X add array, we are still adding here. Then X length arrays from, so we are gonna be getting the length of a particular queue over here. So let me even go through this particular section. So X length of key, that's gonna be better uptime here. And website, let me run this. We are getting 6 over here, and we know that we just simply added 6 requests here. If confusing, so let me read it again. So X read I'm gonna be reading. Count is gonna be suppose 10 by default, because I know I have six of the request milliseconds. I'm not gonna be blocking it. The stream name is gonna be that's streams. The key is gonna be better. The key can actually be anything. For now, I have named it better uptime for website. And suppose I wanna read from the beginning. Let's simply enter. So I have 6 values over here, starting with 1, goes till 6. Hence, whenever I write x length of the key better uptime, this is the key of my queue that I have created. So using this, I'm gonna be getting the length, and ultimately there are 6 values in that. So pretty simple. So this is something that we've done as well. And integer, so ultimately we will have times in milliseconds and the sequence number. It's pretty simple. This is the ID, the entry ID that I'm talking about. So the first part is the millisecond, the second part is the the sequence number. So we have milliseconds time and the sequence number we have here. Again, we could have read through them, but it will take a lot of time, hence I'm not gonna be doing that. And I just downloaded something before a while back. So well, I didn't really get that. That's crazy. Download markdown. Oh, we don't really have anything here. Never mind, forget that. Okay, so we have gone through this particular section as well. X add race USA. That's interesting. This is where we are specifying the ID, that the ID should be somewhere between 0 to 1 and 0 to 2. And this is the ID. Here we are specifying the ID on or on. So this is sort of the this place is mainly for the timestamp. This place is for the sequence number, and here we are just simply specifying the IDs from or on side. That is also possible. Then racer, and this is the data that you are just simply storing. So this data you are storing. This is the ID. This is the stream name. Same thing you can see here as well. So when you are just simply getting something in the range, so you have to just simply call this x range method here. And similarly, x read for reading. You provide the key, provide the ID. What should be the ID? Count should be what? Block should be what? And that will make the things work. And then we can just simply add it. And while adding it here, what we are doing, star we are adding it here, right? We can get the length. And apart from this particular thing, these two things are same. Here we are just simply adding the ID from or on side. So same here we are doing x client add. This is the key, this is the ID, this is the data that we are adding. So these types of things you can just simply get done on your own, and this is simple, pretty simple. Then we can just simply add here. We are doing the same thing. And x add race uses 0 asterisk. It just simply means it will be just simply getting changed as per the need. Getting data from the stream. So let's simply go through it. We have added the data. Now it's time to get the data from the stream. Same thing I'm gonna be going through here as well. So getting data from the stream. This way we can get it using the command JavaScript. This way we can just simply get using command line. So what we are actually doing here, that querying by range, x range or x rev range, whatever that is. So x range, and we can just simply get them using x range here. So we have minus and plus here. That does not make sense. So to query the stream by range, we are only required to specify two IDs, start and end. So here we have to just simply specify the ID. The range returned will include the elements having start and end as ID. So the range is inclusive. The two special IDs minus and plus respectively mean the smallest and the greatest ID possible. So they automatically get the smallest and greatest IDs possible. So if I just simply read like this, x range, I think that's the one, x range, key is gonna be better uptime and colon website here. Starting should be minus, ending should be plus, and let's simply enter. So it will just simply automatically get the smallest ID and the greatest ID on the basis of that thing. It just simply gets the smallest one and the greatest ID is possible automatically, and just simply shows us the results. So hence we do not need to copy and paste the things. That's pretty much interesting. And the same thing can be done here as well. So it's simple, right? So race minus plus, this is just the overall structure. If you understood this, the same thing is implemented here using client object and the method. Okay, so that particular thing is done as well. And then we have what? Then we have okay, we can use specific IDs as well. We have gone through this particular section. Same thing is done here. Instead of using plus minus, you can use specific IDs for the range. And then we can add the count as well. We've already done this particular thing. Similarly, you can add the count here too. So done with this particular thing. And then this is something interesting that we want to start from here. Okay, this is just the starting point, so the same thing we did over here, didn't we? So we want to start from here, we want to go till the last value, because that will find the greatest IDs, and we want to get the 2. So to continue to iteration with the next 2 items, I have to pick the last ID return, that is this, and add the prefix to it, this the resulting exclusive range intervals, that is in this case can now be used as the new start argument for the next range. So ultimately what happens, whatever we given here, that's gonna be the next range value here. That is fine. And as we just simply keep so now that we've written 4 items out of stream, that only 4 items entries in it, we try to retrieve more items, we will get empty array. Okay, so ultimately this keeps changing, doesn't it? 7 3 here, 8 5 is here, that is right. So show full output here. So we have 8 5, we have 7 3, now we are using 7 3 over here. So as you keep changing it, that's fine, right? So you are gonna be getting nothing, that makes sense. So this thing is done as well. Then we have x rev range. What is the use of this? Know that x command takes start and stops argument in reverse order. So it is the reverse. Okay, fine. Stop arguments in reverse order. It will be getting the stuff, but it will be like plus and minus. It just simply gets the job done in the reverse order. Okay, so this is how we can just simply get the things done. We've sort of done this. I mean, yeah, I mean, overall things are done. Now you can just simply go deeper into them, and just simply do those things in action. As for right now, we have to just simply go through a lot of things, so we will be just simply going ahead. Listing for new items with xread, so you can just simply list the new items using xread. So xread count to streams, and this you can just simply 0 stands for starting. The same thing we ran here, right? Didn't we? A while back. This is the command that we ran, xread and all this thing. So yeah, we have gone through this particular section as well. Again, if you are getting confused, the same command is used here. Hasn't it been not consumer groups, listing group. Okay, so the ID is gonna be 0 0. So from the starting point we are gonna be reading 2 at a time, and we'll just simply keep going ahead. So this thing is done as well. And next, what is the next thing that we have to go through? Just a minute, coming back to this one. Xread blocks 0 streams. Okay, this is fine. Consumer groups, here is the finally we got consumer groups. How we are gonna be creating the consumer group? So when it comes to the consumer, let's simply read through it. It's pretty much interesting. Anyway, how long has it been? It's been around 1 hour and 7 minutes. Okay, it's 4:52. Let's do one thing, take a break for a while, for around 10 minutes or something. I'm gonna be taking a break. After that I'll be back and then continue from here on. Okay, so bye bye, take care. And after the break I'm gonna be back and we'll continue with the consumer groups. We actually have to go through a lot, so we'd better just simply get it done the right way. The same things are gonna be implemented over here, and it's gonna be pretty much fun. So see you soon after 10 minutes. Until then, take care, bye bye, and see you.